Awesome Physics kids. Just want to talk about how to do the graph for the first lab. You don't have to graph the stuff in the second lab. Just asking for a graph for the data in the first lab. Graph for the 3 silly walks. And this is obviously a tremendously simple graph, and it's just to prove a point. And I want to share this point. All right, we are graphing distance, which is going to be measured in meters, over time, which is going to be measured in seconds. Now the distance, it's all 20 meters. So you make the mark, it's 20 meters. The time, I don't know how long it took you, but okay. Key things to pay attention to. We have 0 seconds here. Each spacing needs to be exactly the same amount of space for you to say anything about anything on a graph. So the distances, if we were doing multiple distances here, 10 meters here needs to be 10 meters there. It would always have to be the same along any axes. If you mess that up, your graph has no meaning in the real world whatsoever. Don't mess that up. So your graph should have a title that is clear and understandable. How about distance versus time for Silly Walk Lab? All I need. Now, you indicate what the time was. Maybe you had 2.5 seconds for your first run. Maybe you had 4 seconds for your next run. Maybe your next one was 3, 4, 5, 6, 7. Maybe it was 7.5 seconds for your next run. All right, do you only have 1 point for each graph? I don't think so, because at 0 seconds, where were you? 0 meters. So each one of these has 2 points. Right? So now draw a line and connect them. All right? Pay attention. I'm about to make my point. Okay, so we have 3 different lines connecting them. Walk A, B, and C. Great. Which one was fastest? Ah, you didn't say that fast enough. Here's the point of this. How does its plot on the graph show which was faster? Do you really have to spend a lot of time thinking about this? No. You look at the slope. Now, you learned slope as this. Rise over run. I hope you're learning in this class everything is about units. So the question would be, what are the units of rise? Meters. What are the units of run? Second. What is the units of slope? Meters over seconds. What are meters per second a unit of? I'll give you a second. Right. Meters per second equals velocity. So in all cases, the slope is equal to the velocity. Now when you look at it, who's the fastest? Biggest slope. Who's the slowest? Smallest slope. Can you see how quick and easy it is to figure that out? When you're looking at distance time graphs, they speak to you if you know what the slope is. Are you supposed to remember that? Absolutely not. Every time somebody says, hey, what's the slope? Look at the units. What are the units of rise? What are the units of run? If it has no meaning, that's fine. If it does have meaning, make sure you grab what that meaning is. Slope is really important. It will help you identify all things about a graph. So that's the only graph I want you to do, but I want you to look at what the slope is. You don't have to do a slope calculation. But let me ask, did you already do a slope calculation? Well, look at your data table. Did you calculate velocity for each of these runs? Isn't that the slope? It is. So why don't you go ahead and write in what the velocity calculation is so you can identify what the slope of each graph is. That's useful. That's where graphs get smart. The last thing you might want for this lab, is how would you do the front page? The front page should be a separate piece of paper. The title, the Silly Walk Lab and distance determination. All right. Your name physics. Now, would you help me out and put what physics days and periods you're in? So physics, Monday, Tuesday, second period. You don't have to tell me the lab period, but Monday, Tuesday, second period, that lets me know what class you're in. That helps me. All right? Mr. Johansen. Mr. Johansen. Don't say Mr. Yo. Mr. Johansen. And then how about the date? How about the date you handed it in? That'd be handy. Might want to put the date it was due. I don't really care. But the date should go there too. All right? That's all. But that should be on a front piece of paper. Now, I'll tell you this. We do physics because in the end, it's kind of fun. So I like it when on your lab papers on the front page, you have kind of fun with it. Go find some physics cartoons. Go do some cute physics drawings. Put some of your equations along it. Make the front page look like it was fun. Maybe do a picture of you doing the lab. Whatever. But entertain me. Make the front page fun. If you don't, no points off. That's fine. But entertain yourself too. Physics should be fun. Thanks for watching.